You are standing in a cabin in Nagano, Japan, in the winter of 2011. The grid is down. Snow has cut the power line for 6 days. Your phone is dead. The heater runs on battery. That battery is nearly gone. You have one night before the cold inside matches the cold outside. Now, I want you to sit with that feeling for a moment. Because this is not a survival story. It is the moment I learned something. I am Haruto Sato. I have spent 20 years studying energy systems that work when the grid does not. My father worked in rural electrification before me. He taught me to trust what I could measure, not what I was sold. That night in Nagano, a man showed me a rotating magnet setup smaller than a shoebox. It was turning, and it was powering his lights. His phone was charging. By the end of this chapter, you will know exactly how to build one for $15. And here is what matters. You will understand the actual mechanism, not the mythology. I will show you the 4 parts, the math that makes it work, and what it can truly power. Stay with me to the end, because I need to tell you something most people get backwards about where the energy actually comes from. That changes everything about how you use this setup. Let me start with the core principle. It is not new, and it is not magic. In 1831, Michael Faraday discovered that a moving magnet near a coil of wire makes electricity. The magnet spins. The magnetic field moves through the coil. The coil feels that change. That change is an electrical signal. This is Faraday's law, and it is the entire foundation. The faster the magnet spins, the stronger the signal. The stronger the magnet, the stronger the signal. Neodymium magnets, the ones I use, are the strongest permanent magnets you can buy for under $10. A copper coil wrapped in the right pattern costs maybe $3. Add a simple circuit to convert the signal into usable power, and you are at $15 total. Now, here is where most people stumble. They think the setup makes energy from nothing. It does not. You spin the magnet. Your effort becomes electricity. But here is the secret. You can spin it many ways, and some ways waste far less of your effort than others. That is what the next chapter teaches you. The specific wire pattern that keeps nearly all your input alive in the output. Before we wind that coil, you need to see the full setup assembled. Now you have your magnet spinning, so let's talk about the wire that captures it. Most people grab any copper wire and start winding, and they lose 30% right there. The pattern matters more than the gauge. I learned this from my father's notebooks. In 1831, Faraday proved that a changing magnetic field through a coil induces current. More turns means stronger induction. This is the first rule I never break. But, and this is crucial, those turns must be wound tight, uniform, and in one direction. Loose winding creates air gaps between the wire. The flux leaks out like water through cloth. Watch how I hold the tension. Steady hand, constant pull, every loop sitting flush against the last. Magnet wire, the enameled copper kind, is what you need. The insulation lets turns touch without shorting. I use 22 gauge, thin enough to wind many turns, thick enough to carry current without burning. Here is where most people miss the real secret, the coil geometry itself. A tight solenoid, wire wound in a helix along a cylinder, confines the magnetic field inside. Loose spirals or random coils scatter flux in all directions. You are broadcasting energy you could capture. The formula is simple. More turns, faster flux change, tighter geometry equals higher voltage. I aim for 40 to 50 turns on a cylinder 2 inches in diameter. That gives me the inductance to match Faraday's law without wasting copper or effort. Now, here is what I have to be honest about. There is no magic pattern. I have heard people claim Tesla's bifilar coil winds 2 wires side by side for free energy. It does not. 2 wires wound together simply divide the output between 2 paths. What it does do is reduce a specific kind of interference. Nothing more, nothing less. The real work is uniform tension, consistent spacing, and the right number of turns. I check each coil by eye before I even attach it to the magnet. If a turn looks loose or crooked, I unwind that section and do it again. 1 hour at this stage saves you days of troubleshooting later. But that coil is only half the conversion. What happens when it spins is where you see the payoff. Before the magnet can keep moving, we need to remove the friction fighting against it. Now your coils are wound tight, and here is where momentum matters most. You are holding a magnet that wants to spin, but friction is eating your work. I learned this the hard way on my father's test bench in Yokohama. He handed me a cheap bearing and a bicycle hub bearing side by side. I watched the cheap one slow down. The good one kept moving. The difference was not magic. It was geometry. A bicycle wheel bearing is a race of steel balls held in a cage. Those balls roll, not slide. Rolling loses far less energy than sliding does. When I swap the bearing in my magnet housing, I am lowering resistance. Lower resistance means the magnet spins longer on the same push. Longer spin time means more passes through the coil. More passes through the coil mean more voltage pulses reaching your device. Here is what I do before I swap. I spin both bearings by hand. The cheap one stops in 3 seconds. Count it out loud. The bicycle bearing spins past 10 seconds. Feel the difference yourself. That gap is friction loss converted to heat. Wasted. Now, the part most people miss when they are building this: the bearing has to be packed tight or it will rattle and wobble. A wobble scatters your magnetic flux. Scattered flux produces nothing. I use a simple shim, a thin metal washer, to seat it dead center. Spin it again. If it hums, it is true. If it chatters, adjust. This is where patience pays. I have spent an hour on this step alone. Once it spins smooth and long, you are ready for what comes next. But here is what I need you to understand before we move forward. A better bearing keeps the magnet moving, yes, but it does not create motion. You still have to spin it. The bearing only preserves what you give it. That distinction changes everything about what this device can actually do for you. With the bearing spinning freely, you now hold the mechanism that my father and I tested for weeks in our Nagano workshop. But here is where most people stop, and here is where they are wrong. You are not standing in front of a power plant. You are holding a supplement. That magnet, spinning at 2,000 revolutions per minute, generates roughly 0.3 volts of direct current. 0.3 volts. Let me be clear about what that means. It will charge a phone battery, but not quickly. Plan 6 to 8 hours for a full charge. It will power 3 LED bulbs at half brightness. Not daylight, useful darkness. It will run a small transistor radio if you spin it steadily for 20 minutes. Now, here is the part that changes everything. And this is the secret I promised you at the start. The real power is not in what one unit does. The real power is in the stacking. I have seen cabins in Yamanashi Prefecture use 8 of these units, each wired in series. 8 units at 0.3 volts each become 2.4 volts. Add a simple capacitor bank, and you hold something that works. You charge your phone slowly. You run your lights. You power a water pump for a day. This is why Japanese engineers and remote landowners built these. Not for electricity independence, for electricity resilience. When the grid fails, you do not freeze. You do not sit in darkness. Look at what we have walked through together. The coil winding that maximizes flux change. The bearing that kills friction. The magnet that moves because you moved it. Every step honors one principle: mechanical energy in, electrical energy out. No fuel, no delay. The mechanism is Faraday's law, unchanged since 1831. The stacking is patience and geometry. Now, I want you to try something simple. Take a flashlight apart. Spin its copper coil by hand. Feel how the resistance changes. That sensation is the same force your magnet fights. That is what you have just mastered. I read every comment you leave, and I want to know, how many units would you build if power went out tomorrow for 1 week? Tell me in the section below.